Hello, dear students. We now have the last chapter for this semester, which is about simple linear regression and correlation. Through this chapter, we talk about three topics. First, we talk about simple linear regression equation. Here, uh, the first topic that you talked about, that we are going to talk about, is finding the equation of the linear regression. Here, we need to find a linear equation for the linear regression. We will talk about this later on, how to find the linear equation. And then we talk about the test of linear regression, test of linearity of the regression. And then finally, we talk about the correlation. We talk about these three topics through this chapter. Uh, First, here, these are only the basic things and derivation of the rules. This is the linear regression equation. This is the linear regression equation. Y hat, this symbol, this one reads as hat. Y hat is alpha hat plus beta hat x. Alpha hat plus beta hat x. Okay, this is the linear regression equation. In finding this linear regression equation, we just need to find alpha hat and beta hat. We need to find these two, okay? We'll have a formula for finding each of these two. So here, we just need to find alpha hat and beta hat. Based on the given data, we can find both of them. It's easy to find them if we know the rules. The rules in this chapter are not really a lot. There are only a few rules here in this chapter, and one of the questions of the final mark of the final test or final exam will be about this topic. Will be about not only this topic. Will be about this chapter. So there is a question in the final exam about this chapter. Okay, about those three topics that I talked about. First, a linear regression equation, then test of linear regression, and then correlation. We have these three things. Okay, be sure that there will be a question in the final exam about this chapter, and there is only a few rules in this chapter, so you could cover it. Okay, first, finding the linear regression equation. The linear regression equation is this one. Y hat is equal to alpha hat plus beta hat x. Here we just need to find beta hat and alpha hat. Let's see how to find alpha hat and beta hat. These are nothing you could skip these. Only this one. Look, these are the scatter diagram of a given data. If it is in this form, look, if it's in this form, we say it is the slope here is positive. The slope here is positive. So it's a positive slope. And here, if it is in this direction, if the data arranged in this direction, we say this is a negative slope. This is a negative slope. Uh, in finding the values of alpha hat and beta hat, we use the method of least square. We use the method of least square. These are actually nothing. You could. These are the derivation of the rule. We don't need to. You don't need to know these. You don't need to know these. How to derive the rule. This one also you don't need to know these. You just need to know these three things. S sub y, S sub xx. Sorry, S sub xy, the first one is. This one is S sub xy, and this is S sub xx, and also S sub yy. You need to know these three formulas. Okay? We say beta hat beta hat is s sub xy dividing by s sub xx. This is beta hat. Okay. And then is alpha hat is y bar minus beta hat x bar. We studied x bar and y bar. They are means, mean for y data and mean for x data. Here, y bar is the sum of all elements of y column, or all the sum of all data for y, dividing by the number of data of y. Let's say we have 10 data for x and 10 data for y. Okay? Here, y bar is the sum of all y values, dividing by 10, and x bar is the sum of all x values, dividing by 10. So, as you see, alpha hat depends on beta hat. So you must first find beta hat, then x bar, then y bar, and then we could find the value of alpha hat. Okay. Here, beta hat is s sub xy, is s sub xy, which equals to s sub xy is the sum of xi, yi. I'll tell you how to find this summation. Then minus 1 over n, sum of xi, sum of yi. This is how to find s sub xy. And for finding s sub xx, look, that's these two rules which are given, okay? S sub xx is the sum of xi squared minus 1 over n, sum of xi all squared. Now let's see how to find these, summations. If you have some data for x and some data for y, let's take a few data for x and y. We have 5 data for x and 5 data for y. Here in this chapter, the data for x and y must be the same. We must have the same number of x and y. Here, let's say if x to be 1, 2, 3, 4, 5. Okay, and y to be 11, 3, 12. So let's say, let's take some small numbers, 6, 3, 4, then it's 5, and then 7. We have 5 data for x and 5 data for y. Let's see how to find these summations. For the sum of xi, it is the sum of all elements of x. It's the sum of all elements of x. It's 1 plus 2 plus 3 plus 4 plus 5. Okay? Which is 15. The sum of yi is the sum of all elements of y. The sum of all elements of y, which are 6 plus 3 plus 4 plus 5 plus 7. It's 25. Okay? Now, what's the sum of xiyi? The sum of xiyi. Sum of xiyi is the multiplication of x values and y value to the corresponding y values, and then find the sum of them. 1 times 6 is 6, plus 2 times 3 is 5, so it is 6. So 1 times 6 is 6, 2 times 3 is 6, 3 times 4 is 12, 4 times 5 is 20, 5 times 7 is 35. The sum of these is the sum of xi times yi. Okay, 35 plus 20 plus 12 plus 6 plus 6. It's 79, I think. Yep. at 79. It is 79. So now we have these three. And then finding this one, sum of xi squared. That means here we square all the x values and then we find the sum of them. 1 squared is still 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. The sum of these is 55. So the sum of xi squared is 55. Then what's this one? What's this? It's the sum of xi all squared. We already found the sum of xi. We already found the sum of xi. This is the sum of xi. This one is squaring it. It is 225. So the sum of xi squared is 225. As the sum of xi, which is 15, squared is 225. Now plug these all into here. This dividing by that, okay? You get the value of beta hat. You get the value of beta hat, okay? May takes time, but it's so easy. It's really easy how to find it. It's only calculating these numbers, okay? It's easy to find. After finding beta hat, look here, n is 5 for this one, for this sample that we took. As we have only 5 data for x and y, n is the number of datas for x or for y. For both must be the same. So both are 5. So here n is 5. Then for finding alpha hat, as we said, alpha hat is y bar minus beta hat x hat. Sorry, x bar. We need to find y bar and x bar. How to get them? Here, from data of x and y, we could get x bar and y bar. X bar is the sum of all x values dividing by the number of 1, 2, 3, 4, 5, dividing by the number of x values. So the sum of them is 15, dividing by number of x data is 5, which is 3. This is x bar. And y bar is the sum of these dividing by 5. It's 25. Y bar is 25 over 5, which is 5. Now we have x bar and y bar. Plug y bar, beta hat as we found before. And x bar here, you get alpha hat. After finding alpha hat and beta hat, just put them here. Y hat is alpha hat minus beta hat x. Put alpha hat and beta hat here to get the equation. We will have an example about this, okay? So that's it. It's our equation that we need to find. In this equation, only 2 things we need to find, which are alpha hat and beta hat. Here, in this type of Casio calculator, in this Casio calculator, in this model of Casio calculator, you could find these all. Look, these are the steps for finding these. For finding the sum of x squared. That's it. You just push these buttons. And then for finding this, or for alpha hat and beta hat, you could find them by pushing these buttons. Okay? And also you could look at watch videos on YouTube to know how to use calculators in finding these. Okay, but try to watch those videos which about your calculators model. Okay, these are the steps of finding these things by using this model of Casio. Okay, but here I prefer to solve it by hands. Okay, I prefer to solve it by hands because during final exam you may ask you may ask for doing it by hand rather than using calculators to get the final result. Okay, now here we have an example. It says obtain the equation of the least squares regression line y on x for the following data. Here we have given these data for x and y. We have given these data for x and y. We need to find the equation of the linear regression. We need to find the equation of the linear regression. You must know that the equation of the linear regression is y hat is alpha hat plus beta hat x. You must know this. In this equation, we need to find both alpha hat and beta hat. That's enough. If you just find these and then plug it to the equation, you get the results. You get this equation. Okay? It's only asking for finding this equation. Let's see how to find this equation. How to find this equation. We need to, as I said before, we must first find beta, as alpha depends on beta. Okay? Because here we say alpha hat is y bar minus beta hat x bar. X bar. Here we need to find x bar, y bar, and beta hat to get the value of alpha hat. First, we need to find alpha hat. Okay, first we need to find the value of alpha hat. Or let's first find an x bar and y. X bar is the sum of these elements, dividing by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, dividing by 10. The sum of these x values dividing by 10 is x bar. And the sum of these y values dividing by 10, and the sum of these all values dividing by 10 is y bar. Finding x bar and y bar is so easy. Then, for finding beta hat, we must find beta hat as well. We say beta hat is a sub xy dividing by a sub xx. We applied how to find these in the sample that we took before. Then, look, using calculators, it could be obtained like this. Okay, but here we calculate it by hands. Okay, manually we calculate it. Beta hat is s sub xy dividing by s sub xx. So s sub xy is sum of xi yi minus 1 over n sum of xi sum of y. And s sub xx is sum of xi squared minus 1 over n sum of x all squared. Okay, it's how to find beta. From the given data, it's easy to calculate each of these. Okay, I told you in the sample that you worked on how to find them. It's easy. The sum of yi is 681. The sum of xi is 425. The sum of xi all squared is 425 squared. This is 1 over n. This 10 is for 1 over n. Okay, and it's 10. And here, the sum of xiyi we multiply each two corresponding x value and y value. We multiply these two, these two, these two, these two, these two, up to here. And then we find the sum of these. We find the sum of all multiplications of x and y. And that will be the sum of xi, yi. How about the sum of xi squared? I mean this one. This one. We square all elements of x and then we find the sum of the squares. That's it. We square 20, we square 25, we square 30, we square 35 up to 65. We square all and then we find the sum of their squares. We get the denominator. That's it. Now, after finding them all, plug it to this formula, we get beta hat is minus 1.2667. Always take 4 decimal points. Always take 4 decimal points. Okay? Then, this is beta. How to find alpha? We say alpha hat is y bar. Y bar is the sum of all elements of y dividing by 10. The sum of all elements of y is 681. It is 600. Let me write down the equation first. Minus beta hat x bar. And so alpha hat is y bar, which is 681 dividing by 10, as you have 10 data for x and for y. That is 681 dividing by 10 minus. Beta hat is this value. It's minus. Here we have a negative sign for the rule. And even beta hat is a negative value. It's negative. Negative becomes positive plus 1.2667 multiplying by x bar multiplying by x bar. X bar is the sum of all elements of x dividing by 10, which is 422. So 425 dividing by 10. Now find this. It's easy to calculate. So it is 681 dividing by 10. It is 68.1 plus 1.2667 multiplying by 425 dividing by 10 is 42.5. Calculate this and it will be alpha hat. Let's see what's the value. Alpha hat is 121. It is 121.9348. It's 121.9348 minus beta x. Beta is the value that you found. In the rule, we say y hat is alpha hat plus beta hat x. Alpha hat is 121.9348. Then beta hat is minus 1.2667. As this one is positive and this is negative, it becomes minus. So we get this one. This is the required equation. This is the linear regression equation. As you see, we just found the values of alpha and beta. Nothing else. If it's asking for finding the linear regression equation, you just need to find the values of alpha hat and beta hat and plug it to this equation. You get the linear regression equation. So this equation is the required equation in this example. Let's throw this chapter. Anyway, if it asks for finding the equation of the linear regression, just do this. Okay? And be sure that you will see this during final exam, okay? So it's approximately here for it's approximately to do 2 decimal points. Even you could use this one. Leave it with 4 decimal points. Okay, don't round it. Look, this example, it says refer to example 3, which is the previous example. Predict the value of y when x to be 58. Let's write down the equation here. This is the equation. It says if x to be 58, what's the value of y? We say y is 121.93 minus 1.27 multiplied by 58. We just plug the value of x into the equation. We get the value of y. Only y is unknown, so it's just calculating the addition, subtraction, and multiplication to get the value of y. That's it. It is how to find the value of y if x is given. What if y is given and x is required to find? Let's say if y to be 2, what's the value of x? We plug y here. Instead y hat, we use 2. And only x is unknown. We calculate it, we write down for x, and we get the value of x. Okay? This is how to find the value of a variable if the other variable is given. We have only 2 variables in the linear regression equation, which are x and y. If x to be given, we could find y. And even if y to be given, x is x could be calculated. This is the value of x if y, this is the value of y if x to be 58. Here we have a task. In this task, it's not two different data. Look, this one, these data are after this one. It's all together actually, but as it's too long, that's why it's made into 2 rows. It's written into rows. So here, x values are these, and also these are x values, and those which are below are the y values. Now, after finding the linear regression equation, look, this is our linear regression equation in the previous example. We said that y hat is 121.93 minus 1.27x. What are these numbers in the linear regression equation? What are these values? I mean that 121.93 and also that 1.27. What are these? 121.93. This is y-intercept. It's intercept. Okay? It's y-intercept. It is y-intercept. How about this value? This one is the value of alpha hat. So alpha hat is the y-intercept value. And beta hat is the slope. Beta hat is the slope of our linear equation, of our linear regression equation. Here, if beta is negative, as it's negative, we see the slope is negative. Okay? But if beta is positive, we say the slope is positive. Okay? Look, compare this with this equation. I'm sure that you are familiar with this equation. X plus B. I'm sure that you've seen this one in high schools. Okay? I'm Hauke Shea. لە ئامادەیە خوێندوتانە ئەمە هاوکێشەی لاری یەکتر بڕین لاری یەکتر بڕینی پێوترێ هاوکێشەیەکی هێڵیە لاری چییە ئێمە چییە ئێمە کە دۆسیمانەتەوە بێتاکەی ئەگە بێتە سالب بێت لاری سالب باشە واتە سلۆپ سالب means slope لاری means slope okay if beta is negative so we say slope is negative and if beta is positive we say slope is positive. How about B here? B represents alpha. B represents alpha as it's the constant here. Look, it's a constant. We say B or alpha hat is the y-intercept point. This line intersects y-axis at B. Even here, this equation, the plot of this equation intersects y-axis at alpha hat. Okay, that's it. Here we have this task. In that task, we need this. That's why I talked about that. Look, in this given data, look, it says with a linear regression model, x, y, okay, y on x, using method of least square. Here means find the equation. We say y hat is alpha hat plus beta hat x. We need to find beta hat and alpha hat and plug it to here in this equation. You get the equation. You'll answer the first part. Okay. Here the answer here. We must have x also. Then it says what can you infer from the estimated value of the slope? Look, the estimated value of the slope is beta. Is the value of beta. Okay, the slope is the value of beta. We say if beta is negative, we say since beta here, beta is positive. Since beta is positive, is greater than 0, so the slope is positive. You just say that for answer for this question. That's it. The slope is the value of beta. Okay, as it is positive, so means it's in this direction. It's increasing. It is increasing. What if the slope is negative? The graph is like this, and it is decreasing, as you see. If the slope is negative, it's increasing. If the slope is if it's positive, it's increasing. But if the slope is negative, it's decreasing. And then it says predict the value of y when x be 58. Just plug 58 to here, you'll get the result. Okay, plug 58 into the linear equation, you'll get the value of y. Even in this example, it says find x bar. It's easy. It's the sum of these all dividing by the number of data 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dividing by 10. Y bar is the sum of these dividing by 10. S sub x, S sub y, S sub xy. We already studied these formulas, the formula for finding each of these. You must memorize those formulas. Okay? Even the other questions here about this task, it says find alpha hat and beta hat. It's easy. Okay? And then it says write a fitted simple linear regression model for the above data. Means it says find the equation here. It says find the equation. In the equation we just need alpha and beta, alpha hat and beta hat. In the previous part, you found alpha hat and beta. Just plug these two into the equation, you get the results. Next, estimate the number of defective items produced by the machine if the speed is 380. Return to the question and then determine what speed and what is defective items. Okay? Okay. After finding them, after knowing which one is, it represents x or y. The speed, let's say it's x. The speed is x. So y could be obtained. Just plug it to the equation, you'll get the value of y. Then we have test of linearity of regression. As I said, we have three topics in this chapter. The first topic, it was only about finding the equation. Okay, it was only about finding the equation. And in the equations, we have two components, alpha hat and beta hat. Alpha hat represents the y-intercept. Beta hat represents the slope. Okay, and also we studied if we have given a value of x to find the value of y. We just plug the value of x into the equation, we get the value of y. And even if we have given the value of y, we plug it to the equation to get the value of x. We only studied these things up to now. Now we have test of linearity of regression. Here we have two methods. We only have two methods, T and F. We only have these two, T and F, for finding the linearity, the test of linearity of regression. Let me check here first. Look, okay. As I said, we only have two different tests here. We only studied two different tests for linear regression, for tests of linearity of regression. We say there are t-test and f-test. T-test and f-test. And their formula are really easy. No worries about that. The formulas are so easy. Here, test of linearity regression. As I said, we have t-test and let me find some space. I'm looking for some space actually. Okay, here's good. We have t-test and f-test. When do we use these two? We say, let me tell you what's one-sided and two-sided equations based on this table. Look, if we have given the equation to say, if, is there any evidence to be, let's say, something to be zero? Means beta equals zero is null hypothesis. And then alternative hypothesis, or H1, is beta doesn't equal to zero. And this is called two-sided. Okay, two-sided test means if beta to be zero, beta to be zero. What if beta doesn't equal to zero? Means beta is positive or negative in both sides. The alternative hypothesis is two-sided. It's greater than zero or less than zero. So it's positive and negative. Okay, it could be positive and it could be negative. Beta H1, H1 in H1 in the alternative hypothesis, we say beta could be positive or negative. This is called two-sided test. What if in the question it's asking for only the positive test? Okay, on the right tail test for the positive slope, if it's asking for the positive slope, if it is asking for the positive slope, we say it is H0. H1 is only beta is greater than zero. Why do we say beta? Why don't we say alpha? As we said before, beta is the slope. Beta represents the slope of the linear equation. If beta could be greater than zero, and it could be less than zero. Okay, it could be. If it's asking for the positive slope, we use this one. Okay, it's this case actually. If it's asking for negative slope, it is this case. Each of these two cases is one-sided. This one is only the right-hand side of 0. This one is only the left-hand side of 0. Okay? Even if it says a right tail test or left tail test, it's the same as to say positive slope or negative slope, respectively. Okay? Positive and right are the same. Negative and left are the same also. Okay? Let me return to here. That's here. As I said, we have two tests here in this chapter. We just have two tests with the test of linearity of regression. If this two-sided, I explained it. I explained it just now. What's two-sided? What is one's positive side and what's negative side? Okay. If it's two-sided, both could be here. Two-sided is two-sided. If in the equation it doesn't say positive or negative, right or left, or those things, okay, means it's two-sided, means it's asking for both sides. So beta, in the alternative hypothesis in H1, we say beta doesn't equal to 0. If it doesn't equal to 0, it could be positive or it could be negative, both included. Okay, means it's two-sided. If it's two-sided, we can use any of these two tests. We can use any of these two tests. What if this one-sided? We only can use t-tests. We cannot use f-tests for one-sided problems, for one-sided test. Okay? For one-sided test, we cannot use f-test. We only can use t-test. So now we conclude that t-test could be used for both two-sided and one-sided problems. But f-test is only used for two-sided ones. Okay? Now let's try to talk about both of them. But you should know them both if it's two-sided. And in the exam, it may ask for using a specific method. If it is two-sided and it's asking for using f-test, you must use f-test. What if it's asking for t-test? You must use t-test. What if it doesn't ask for using any of them? If it doesn't ask for using a specific method, you are free to use any of them. Okay? So generally, as I said, t-test is used for all the cases, but f-test is used for only the two-sided test. Okay? And also, we could use t-test for two-sided test also. Now, here, we have tests of linearity of regression. We have some steps for doing it. These are nothing. Okay, just read these and to know. Read and know these. Here we have sigma squared. What's the concept of sigma squared? We need to find the variance. We must find the variance. The variance is sigma squared over s sub xx. We must first find what's sigma squared. So you know partial squared, not sigma squared. It is partial squared, not sigma squared. Sorry. So partial squared is 1 over n minus 2. 1 over n is the number of data. 1 over n minus 2 multiplying by s sub yy minus beta hat s sub xy. That's 1 over n minus 2 times s sub yy minus beta hat of s sub xy. So at the beginning, we talked about the formulas for finding s sub xx, s sub yy, and s sub xy. Everything through this chapter depends on those three things. Everything. Okay? Look, for this one, for finding partial squared, what we say? It is 1 over n minus 2. S sub yy. Beta hat. Even beta hat depends on s sub xy dividing by s sub xx. Okay? Multiplying by s sub xy. Look, everything depends on those three formulas that you talked about before, which are s sub xy, s sub xx, and s sub yy. You must know those three formulas. And you also must know how to calculate them. This is partial squared. So plug this to here, you get variance of beta hats. It's a variance of beta. This is the procedure. We now talk about the procedure. In the first step, we write down the hypothesis. If it is two-sided, we say H naught is beta is 0. H1 beta doesn't equal to 0. And these are H naught and H1. H naught and H1. If it is two-sided, what if this positive slope? We say only null hypothesis is going to be changed. H1 becomes beta is greater than 0. Okay? What if there's negative slope? Here, H1 becomes beta is less than 0. That's all. That's everything here. In this step, we just write down the null hypothesis and the alternative hypothesis. We say these hypotheses relate to significance of regression. If we fail to reject H naught, we may conclude that there is no linear relationship between x and y. This may imply either of these two situations. First, x is a little value in explaining the variation of y, and therefore the best estimator of y for any value of x is simply y hat equals y bar. Or the true relationship between x and y are not linear. If you have these two cases, means we fail to reject H naught. In the second step, we have stating the decision rule. We state the decision rule. Here, if it's asking about why don't we use Z test and we use T test, let's insert in this context. Okay? Once we state that it was F test approach to carry the further the service two-sided test. Okay? Look here. It's explained here that where do we use F test and where do we use T tests? This option only applies for two-sided tests. So F-test used for only two-sided tests. Furthermore, we can use T-test approach rather than T-test, Z-test, sorry, approach simply because the number of paired observations is small. Here, In all examples that we have here, the number of data doesn't exceed 30. Doesn't exceed 30. It's always less than 30. Okay? That's why we use t-test. But f-test could be used for even those which are greater than 30. For even those which are greater than 30. That's it. You see, the decision rule is to reject H naught if the compute test statistic lies in any of the critical regression, either in the left tail or in the upper tail. We have these cases. Let me tell you here based on this table. Based on this table, we say if t-test is less than minus t of alpha over 2 and n minus 2, we reject H naught in this case. Even if t-test is greater than t of alpha over 2 and n minus 2, we still reject H naught. We could explain here. Let's say this is minus t of alpha over 2 n minus 2. And this is t of alpha over 2 n minus 2. Okay? N minus 2. Now, we say if it is not in this region, if it's not between them, if it's greater than that, greater than the positive one, or if it's less than the negative one, if t-test is here, if t-test is here or here, if it's not between these two, we say we reject H naught. But if it's here, we have failed to reject H naught. Even you could use these, any of these. Okay? That's it. It's in the case if it's two-sided. If it is two-sided. What if it's one-sided and if it's positive? We say if t-test is greater than t of alpha over 2 and n minus 2. We reject H naught. And if this left one or negative one, we say if t-test is less than minus alpha over 2, sorry, alpha and n minus 2, we reject H naught in this case. If not, we don't reject H naught, and we have failed to reject H naught. We have these three cases to stating the decision rule. Okay? We just write down the decision. Okay? We say if t-test is less than t of alpha over 2 and n minus 2, or greater or less than that one for the both sides, and for one side we write down the conditions. We say compute the test statistic. Now we compute the test statistic. We have this rule. So this one is. This is the test statistic. It depends on expectation, variance, and beta hat. Expectation, variance, and beta. Or we could say it is variance, it's beta hat, dividing by square root of variance over s double x. Variance over s double x. S sub x x. That's all. Here, we just replace this one by 0 as the null hypothesis. In the null hypothesis, it's always 0. And in the null hypothesis, we always say beta to be 0. But in the alternative hypothesis or H1, we say beta doesn't equal 0. It's for two-sided. For the positive one, we say beta greater than 0. For the negative one, beta to be less than 0. Okay, that's we have these three cases for null hypothesis, for the alternative hypothesis. That's it. And then after finding the test statistic, we make the decision and conclusion. Then we write down the statement that we could reject H naught or not. That's it. Can you reject H naught, or you have failed to reject H naught? We just write down. Here you have only these 4 steps. We have 4 steps. First, we write down the hypothesis. In the second step, we write down the stating. We state the decision rule. We state the decision rule. Here we say we reject S naught if, let's say, t test. It's for the case if beta equals 0. It's for this case if beta equals 0, it's for H naught, and H1 states that beta is bigger than 0. Okay, if our hypotheses are these, this H1, we say in step 2 we just write down that we reject H naught if t test is greater than t of alpha and n minus 2. Here in this step, we also find this one. It's from the table. We can find it. N is the number of data. Alpha should be given in the example. So we can find it from the table, from t table. Then we say if t test is greater than this value, we reject H naught. It's all what you need to do in the second step. Then computing the test statistic, we use this rule for test statistic. We use this one. It's beta hat over square root of sigma squared over S sub xx over S sub xx. But here, for finding the variance, we must find it by using this rule. Be careful with that. This is the variance. You need to find the variance using that rule. After computing the test statistic, what we do, we make the decision. Can we reject H naught or not? Okay, if we could reject H naught, we say we reject H naught because of this. And here we say we reject H naught if these conditions satisfied. In that case, it's in the two-sided one. In the positive side one, we say we reject H naught if this condition satisfied. And here we reject H naught if this condition satisfied. It's for the negative side. We need to write down that condition. We say as TTS is greater than this one, or as TTS is less than this one. That's why we could reject H naught or not. We now have t-test approach. We use t-test first. So, as I said, we have 2 tests, which are f-test and t-test. You should know these conditions in which you could reject the null hypothesis. Okay, we say t-test, it's test that's it's t-test. It's what we find in step 3. It's beta hat. What's beta hat? Beta hat depends on, it could be obtained from a sub xy dividing by a sub x. That's it. And here, this one, we talked about this, how to find the variance before. Okay, just do this, you will get the result. Now, here we have an example. It says in example 3, that example that you talked about before, the example that you worked on for finding the linear regression. It says, test H0 to be beta to be 0 versus H1 beta doesn't equal to 0. This is two-sided one. So in this case, we can use F-test or T-test. Any of them. Both could be used as it's two-sided. But if this one is beta to be greater than 0 or beta to be less than 0, if this one, we cannot use F-test. We just need to use T-test. And even here, we just can use T-test. If one of them is greater or less, we can use only t-tests. But if it says it doesn't equal to 0, means it's both greater or less than 0. Both cases. It's two-sided. So here we can use t-test or f-test for solving it. As you see, alpha is given. Alpha should be given. Now, from the solution to example 3, we have this. Beta hat is this one. N is 10. We already found these. Sum of x is this one. Sum of x squared is that. Sum of y squared, sum of xy. We already found these all. We already found these all. Then s sub xx. Here we must find s sub xx, s sub yy, s sub xy. S sub xx is sum of x squared minus sum of x all squared. Okay, dividing by n. That's the denominator for only this one. It's the same as to say sum of x squared minus 1 over n sum of x all squared. That's the same, this one. As n is denominator for only the second term. That's the denominator for only this one. So it is, calculate this one. Then s sub yy is sum of y squared minus sum of y all squared divided by n. And this an amount. And also s sub xy is sum of xy minus sum of x sum of y over n. Here we have no squared actually. We have no squared there, okay? It is this value. We now have these three. Then what's variance? Variance is partial squared dividing by s sub xx. We already found s sub xx. And also partial squared is we studied this before. Partial squared, we say partial squared is 1 over n minus 2 times s sub xx minus beta hat s sub xy. We already found these two. Just look, we found those two, s sub xx and s sub xy. Plug it to there, and n is 10, as it's the number of data. We could get partial square, and then return to here. We get the result, and it is some amount. Okay. Now we start from the first step. In the first step, as I said, we just write down the null hypothesis and the alternative hypothesis. Now we write down the decision. That's the decision. That's these are, we need to find the alpha also. So t. That's it. We say t value is this one. As it is here, as it's two-sided, we say t of alpha over 2 and n minus 2. What's t of alpha is 0.05. Dividing by 2, it's t of 0.025 and n minus 2. N is 10. Minus 2 is 8. Find this one from the table. You get it. We say we will reject H naught if this one is. If this condition holds. If this condition holds, we reject H naught. If not, we have failed to reject H naught. We see that. Then in step 3, we calculate the value of the test statistic. What's the test statistic? It's beta hat minus beta bar dividing by variance of beta hat. Okay? Or we could say it is beta hat over square root of sigma squared over S sub xx. Here, beta bar is the value of beta which we have in the null hypothesis. It's always 0. Okay? Always use this rule, not the other forms of the rule. Okay? Always use this one. Don't use this one, which is beta hat divided by square root of sigma squared of S of xx. I think it's something like this. Don't use this one. Okay? Always use this one. Okay? We say t-test is beta hat minus beta bar. What's beta bar? Beta bar is the value of beta in the null hypothesis. In the null hypothesis, we said beta is 0. It's always 0. It's always 0. So you get this one. And there's a value here. It's a negative value actually. Then we say t-test is this value. T-test is that value which we have here. It's greater than this value or not. This value is t of alpha over 2 and n minus 2. If it's greater, so if t-test is less than minus t of alpha over 2 and n minus 2, or if t-test is greater than t of alpha over 2 and n minus 2, if any of these two cases holds, we reject H naught. If not, we can. Okay? So it is the fourth step, which is making the decision or conclusion. We just say that. In step 4, we just say we could either reject H naught or not. That's all. Then, using one-way ANOVA or F test, one-way ANOVA or F test, even if it says use one-way ANOVA, it's the same as to say use F test. As in one-way ANOVA, we use F test. We use F test. In one-way ANOVA, we need to have these 3 things. We need to have these 3 things. To find these, we just depend on S sub xx, S sub yy, and S sub xy. That's all. Okay? So through this chapter, it's important to find S sub xx, S sub yy, S sub xy at the beginning. Okay? We need to find those 3 things. After finding those 3 things, it's easy to find everything, as everything depends on those 3 things. Look, SST in the previous chapter بيشو أمانة ما نهبو ل linearity of variance وأنا اشتكي وابو chapter كواسم بونا وابو لا one way ANOVA بيشتر بكار معنانا one way ANOVA ما هبو ل chapter بيشو إلا one way ANOVA أبغى شو أم دوسيا SST SSR SSE أبغى أمس يشتغل أم دوسيا أبغى أمس يشتغل بدوسينو بلام ليرة ليه برا هي كمان بلام ليرة تنها بكار هنا S sub XX S sub YY S sub XY توين بيان دوسينو ليرة SST كاتا شي S sub YY SST أكاتا S sub YY and SSR أكاتا شي بيتا هات أي بيتا هات شو مدوس بوا أكاتا S sub XY دابشي S sub XX باشا جا زربي S sub XY بێتە هات سەرپی S sub XY ئەگەر ئەم دوانە بزانم ئەمە زانرا بێت و ئەمە زانرابێت SSE توانم دۆزمەوە بەڵێ ئەکاتە کوێم دوانە SSE مات کات هەر سێکیان توانم بەهۆی ئەو سێ فۆرمولەی کەوتم S sub XX S sub YY S sub XY بدۆزینەوە باشە ئەنجا دیگری ئۆف فریدەمە دۆزینەوە دیگری ئۆف فریدەم هەمیشە ئێمە کاتیاڕین ئەلفای ئێفی دقیقە ئێفی ئەلفایە ئەلفا کاتانە ئێفی ئەلفا بۆنمە V1 و V2 ئەمە وان نووسراوە لە هینەکە لە ناو لیستی تێبڵەکانە ئەبێت دوو لیڤڵی فریدەممان هەبێت دوو کۆمپۆننتە لیڤڵ ئۆف فریدەمەکە هەمیشە ئەمەیان یەکە لێرە هەمیشە یەکەم دانیان یەکە f of alpha 1 v2 بۆ لەبەر ئەوەی ئێمە ئەڵێن ئەکاتە n-1 هەمیشە وایە بۆ هەرێکیکان n-1 مان هەیە بەڵام لێرە دیگری یەکەم چییە؟ بریتیە لە ژمارەی پارامیتەرەکان ژمارەی پارامیتەرەکان چەندەیە؟ دوو ناقس یەک یەکدان قەت لە دوو پارامیتەر زیاترمان نییە هەمیشەی ئەلفا و بێتامان هەیە زیاترمان نییە باشە کەواتە هەمیشە یەکە ئەوی تریانە کات چی کاتە n ناقس ئەکاتە n ناقس ئەمەیان ئەکاتە n ناقس دوو کەواتە هەمیشە ئەڵێن f of alpha 1 n-2 هەمیشە بەو شێوەیەکی ئەلفاکەش چییە؟ ئەلفاکە ئەبێ بدرێت لە پرسیارەکەی ئەلفاکەش ئەدرێت لە پرسیار ئەوەش ئەوە اینجا f تێست دەکاتە چی؟ ئەکاتە MSR دابەشی MSE MSR دابەشی MSE با بزانین MSR و MSE چۆن دۆزین ئەو لێرە دۆزین MSR ئەکاتە چی؟ SSR کە پێشتر دۆزیمانەوە دابەشی یەک واتە هەر ئەکاتەوە SSR بەڵام MSE ئەکاتە چی؟ SSE کە پێشتر دۆزیمانەوە دابەشی چی؟ n-2 n ژمارەی دەداکانە کەواتە لەمەوە MSR دابەشی MSE یەکەن ئەمە F تێستەکەی کاتە هیچ فۆرمولەیەکی ترمان نییە وەکوانەی پێش و ڤارێنسی تیابێت و ئێنی تیابێت ئەمان نییە بۆ هین بۆ دۆزینەوەی F تست یەکسەر ئەڵین MSR دابەشی MSE MSR چیەکات ئەکاتە SSR MSE ئەکاتە چیەکاتە SSE دابەشی n ناقس ئەو دوان دابەشی F تستەکەمان دەستگەێت ئەمەشە دۆزینەوە تێبڵەکە بەراوردیانەکەین تێو کاتە بڕیارەین ئایا ڕجێکتەکەین یانە سەرکە ئەڵێن چی ڕجێکتی ئێژنۆتەکەین ئەگەر هاتوو F تێستەکە کەەوەی بەهۆی MSR و MSE یەکەمە دۆزیمانەوە ئەمە ئەگەر ئەوە بچووکتر گەورەتر بوو لە چی F of alpha 1 n-2 ئەگەر مە گەورەتر بوو لەوە ڕجێک گەێژنەوە ئەگە وانە بوو ڕجێکتی ناکەین بەس ئەوەنەی باشە لێرە هەر ئەگزامپڵی سێ ئەڵێ بە چی بیکە بە ئانۆڤا بیکە بە بەکارهێنانی ئانۆڤا لە ئانۆڤا ئیشمان بەچێ بێتە هات S sub YY S sub XY تەنە ئەو سییانمان پێویستە ئەم سییانەش پێش دۆزیمانەوە لە ئەگزامپڵی سێ now we compute it's the first step in the second step we compute all sums of squares سیرکە ئەوەی پێشوو کە بەتی تێست دەکەین ئەبێ نەڵ هایپۆتسەکان بنووسێ پرۆسێسەکە بەو شێوەیە باشە بەڵام لێرە پرۆسێسەکە جیاوازە we calculate these three things and then we compute all these sums of squares by formula SST SSR SSE we find these three things okay this is SST this is SSR and this is SSE we find this one okay then in step 3 we complete the ANOVA table you must fill this table Even in the previous chapter, I told you that you need to make the table. These are some of squares. These are some of squares based on the above. First, we write down SSR, then SSE, and then SST. In this order, okay? You need to write down them in this order. Then, for this one, it's 1. For this one, it's -2. This one is -1, n -1. What's MSR? It is this one dividing by 1. What's MSE? It's this one dividing by n -2. We get MSE. How about F test? F test is this one dividing by this one. So, like this. We get F test. It's the table. Here, we say we reject H naught if F test is greater than F of alpha 1 and n -2. Okay, for this example, this is F of alpha, which is 0.05, 1 and n -2. N is 10, -2 is 8. We look for this in the table and we get 5.32. What's F test? F test, this one is 61.5811. Is this greater than 5.32? Yes, that means we reject H naught. We reject it. If it is greater, we reject H naught. If not, we have failed to reject H naught. Here we have a task here. It's for yourselves. Then we have correlation. It's the last topic in this chapter. Up to now, we talked about linear regression equation and also test of linearity of regression. Now we have correlation. In correlation, we only use this formula. We only use this formula. In correlation, we use this formula. It's S sub xy divided by square root of S sub xx, S sub yy. Okay? S sub xy divided by square root of S sub xx, S sub yy. Then, property of R. This is R. This is the correlation. This is the correlation value. It's always between -1 and 1. It must not exceed -1 and 1. It must be always between -1 and 1. It could be 1 and it could be -1, but it couldn't exceed these two values. Okay? So it's always between -1 and 1. We say when R close to 1 implies there is a strong positive linear relationship. If it's close to 1 between x and y. Further, when R to be 1, we have a perfect positive linear relationship. If it's 1. If it's 1, if it's in the positive part, if it's near to 1, we say it is a strong positive linear relationship. What if this 1? If this positive 1, we say it is a perfect positive relationship. But for negative parts, also it's the same, but in negative. We have a negative relationship between x and y if it is near to -1. What if it is -1? We have a perfect negative relationship. When R is close to 0, if it's near to 0, if it's near to 0, either from positive or negative parts, even from negative or positive sides, if it's close to 0, it implies that there is a weak or no linear relationship between x and y. Look at this. For this one, there is a weak relationship between x and y. As you see, the points away from the line. And for this one, it's a bit closer to the line. So it's stronger than this one. This is a strong positive relationship between x and y. And this one is a weaker weaker than this one. Even it's not too weak, but it's not strong as like this one. And if R to be 1, once we draw a line, all the points are on the line. All the points are on the line. Means here we have a perfect positive relationship. And for these, if it's in this direction, look, the points are arranged in this direction. Means here beta is negative, or the slope is negative, or it's decreasing. But for those in above, it's increasing. Point كان بجول الريزبون كالعينة كبوشي ويدرس باشا ليه point كان شو ندرس بون بمشي ونيا point كان كواتا ليه second decreasing كواتا مسلو بكي نيجاتيف ياخد بيتا نيجاتيف باشا ليه من ناقص 0.6 أما زول weak نية relationship in x and y. So the here we have a negative relationship. We have a little strong negative relationship between x and y. Here we have a stronger relationship between x and y, as the points are closer to the line. But here the points are far away from the line. Okay, then for this one, as we draw a line, all the points are on the line. So here r is 1. So we have a perfect negative relationship between x and y. What if we have this? To which direction should we draw the line? We don't know. Yeah, like this, like this, like this. We don't know. The points are not arranged in the way that we know the direction of the line. So it's no correlated. Here, there is no correlation between x and y. What if we have like this? As we have not a straight line, if it is a straight line, we have a linear correlation. Okay? But if it's not a straight line, we need to draw this line, this curve. Okay? And it's not a straight line, means it's a non-linear correlation. Identify this. We have linear correlation and non-linear correlation, and also no correlation. If we couldn't draw the line where to go, okay, so it's no correlation. If the line is a straight line in any direction, no, don't care about that. Okay, we say it is a linear correlation. But if it's a curve like this, or may we have like this, or may we have like this. Okay, these are non-linear correlation. Okay, now we have an example. It says compute the product. So in this verse, compute the product moment correlation coefficient to measure the relationship between x and y variables based on the sample data from example 3. Comment on your answer. Example 3 then correlation كاتوسينو. A correlation depends on these three things. Find this one. It's minus 0.9. Look, it's closer to -1. So there is a strong negative correlation between x and y. As it's negative, it's closer to -1. Okay, so we say there is a strong negative correlation between x and y. So we now have Excel procedures here. We use Excel to do it. If we have a list of data for x and y, look, these are the list of x data, and these are the list of y data. Okay. If you want to find, the tables, or if you want to use Excel for analyzing this as the linear regression, what we do here, anywhere you could click. What we do, we say, we go on to data. Look in the above toolbar, we have data here. Click on it. And then go to data analysis. Go to data analysis in the rightmost icon, okay? Click on it. Here we get this sheet. Once we click on data analysis, we get this sheet. Go to scroll down. So here we have regression. Choose regression. That's it. Select regression and then okay. We get this one. Now, if there is anything here, delete these. Okay. Maybe that's empty also. Once you open the Excel for the first time, it's open. Here, in the first box, we have input X range. Input X range. What do you do? So it's Y range. The first one is Y range. Put the Y values. Look, from the begin to the end, select all. These are the Y values. That's it. And then in the second box, it says input X range. So X starts from this point to this point. Okay. So from this point, it starts from this point to this point. Then here we have output range. We have output range. Choose output range here and then click on the box. Then choose a cell here, any cell, click here. Means give me the result from this box to down. Okay? Then click OK. Once you click OK, you will get the result. That's it. As you see here, look, DF means degree of freedom. In the degree of freedom, one of the degree of freedoms is 1. It's always 1. And the other one is n minus 2. Look, n is 12, as we have 12 data for x and y. We have 12 data for x and y. 12 minus 2 is 10, and the total is 11. Then, here we have SS, sum of squares. Sum of squares. This is SSE. This is SSE. This is SSR. I don't know which one is first. Just check this one, okay? I think this one SSE, and this one SSR, and this one SST. Okay, this is total. Then we have MS. MSE, MSR. We have MSE and MSR. The above one is MSE, which is this one dividing by, which is this box dividing by degree of freedom. It is MSE. And MSR is this box dividing by this one. That's it. These are MSE and MSR. Then if is MSE dividing MSR, we get this back. And then here we have significance F. Significance F. This is significance F. Now, we say if F is this F test, if F test is greater than significance, we reject H naught. But if it's less than significance, we are unable to reject H naught. It's how to analyze this data here. ليلة أم داتا نكه ما قالوتي آية إيش رجع كريانا حبة هو داتا كانوا ليلة بكمبيري أم توانا أتوانين بسايا رجع كريانا باشا وليلة هم مشتكان دراو باشا قرين أو يتوب زاني شي أدوزيتو إنجا ليلة شي كمان هي تيبل دواتر coefficients. coefficients. The first one is intercept واتا أما يكمل يعني نرخي الفا إما نموت الفا is y intercept. We didn't say that. Didn't we say that alpha is x intercept? So this is the value of it, and this is the value of beta. This is the value of beta, as these are coefficients. This is alpha and this is beta. أقبل اللينير ريجريشن كامل بوم بنوسا بس أنت بلان الداتي بس أمنه بعد أميك هاي ليرة باشا هل ليرة وأتوان يكسر اللينير ريجريشن قبل سنة لينير ريجريشن كاكاتا شي أكاتا ألفا ليرة من ناقصة ونيا خوي زائد بيتا x ونيا y is equal to alpha, which is 30.3877 plus minus 0.1651 x, which is كاكاتا c point c وهش حتى أو ناقص 0.5 x. أما بريتيلا شي y x أنا بو بريتيلا linear relation equation linear relation كمان. أما نش إذا كان أماش تي ستاتستيكا كان تي ستاتستيكا كمان تي ستاتستيكا كمان أما بي فاليو كي أما نش شواني ما نوزن لوري نايت أفرقي أوكي أوكي إيش وان بيتي أما ليرة أما إيش وان بيتي ستاتستيك كان إيش وان بيتي أما ستاتستيكي باشا أما ستاتستيكسي تيكي تي تستكي باشا أما إيش وان بيتي واروا أم لم تيبلوا أتوانين بريار بين كآية أم إيش بروجيكت كريانا وليرة شو بها ماشي وتواني ببراول كدني مانا زين إيش نور بروجيكت كريانا أما أجاب إنه بويني بيشو لا چاپتەری پێشوو باسی ئەومان کردووە ئەمە چ کاتێک پێی فالی گەورەتر بیان شتر بوولەوە ئەمە ڕجێکتە کرێیانە باشە ئەمە ئەگەر هاتوو پرسیارەکەی بڵین ئەگە پرسیار بێتەوە لەم چاپتەرە دوو بەشە ئەیوبی بەشی ئەی داتاکە دەیاتی ئەم داتایە ئەم داتایە دەیاتێ ئەڵێ لینە ڕێگرێژن دۆزەرەوەوانم دۆزەر پارتی بی ئەم تیبڵە دەیاتێ ئەڵێ شتانە بۆ دۆزەرەوە لەسەر تێبڵەکەشەوە توانین خۆشتانە دۆزن باشە کەواتە ئەو پێویستی ئێوە ئەنەڵایزم تێبڵە بکەن بزان چۆن ئەم تێبڵە ئیشی لەسەرەکەن چۆن پرسیارەکان چۆن شتەکان لەسەر ئەم تێبڵەوە دۆزێتەوە هۆی کە باسم کردووە ئەمەش کۆتاییم چاپتەرە بوو هیوادارم سەرکەوتوو بن و هەر پرسیارێکیشتان هەبوو بە پێش فاینەڵەوە بەسەر چاو بە پێی توانە بێخەم بن یارمەتیتان ئێمە وەڵامتان ئێمە بەڵام لەوانەیە یعنی تۆزێک کاتیشم کەم بێت لە ماوەی امتحاناتی ئێوەیە وەکو خۆشی امتحانم هەیە بەڵام ئینشاءڵڵا کێشە نایە بە پێی توانە پرسیارەکان هەموو پرسیارکەن وەڵامتان ئێمە بێخەم بن